Electronics are all around us. Pretty much everybody now carries a smartphone with them. There's some electronics in even basic daily life things. Your fridge might have a microcontroller in it. Your car is probably packed with electronics. Even the device you're watching this video on is a lump of silicon, copper and gold. So it's not unusual that the compressor I'm building also will have electronics inside. In this video, let's review in detail what my pump controller consists of, what each component does and why it's there. The most important thing each electronic device must have is a power supply. My controller is no different. The main power unit is a 12 volts off-shelf pulse power supply. In my case, the module is supplied with 230 volts AC, which is converted to 12 volts DC. This power is then delivered to two modules. One of them is a 0 to 10 volts PWM converter, about which I will talk about a bit later. The second one is a buck converter. This little module is responsible for reducing the voltage to 5 volts. Why 5 volts, you might ask? It's because the ESP32, which is the main component of this contraption, requires 5 volts at its input. Without the buck converter, the ESP would burn because 12 volts is too high voltage for its internal regulator. Next in line is the ESP itself. It acts as the brain of the entire thing. Without it, nothing would be done. It's responsible for holding the code, executing it, and reacting to signals provided by external components. It's also deciding whether to set a specific output high, set the PWM duty, use Wi-Fi, print something on LCD, or communicate with an external board using UART communication protocol. Now we get to the accessories of ESP. Let's start with the most basic one, which is the BMP280. It's a temperature and pressure sensor. I did not really need the pressure measurement feature, but since it's there, I will use it. The main function of this component is to measure the temperature of the controller assembly. By this I can more or less tell whether the controller is in a good shape. The module is powered with 3.3 volts and uses I2C to communicate with the ESP. The next active component in line is the ADS1115. It's a 4-channel analog to digital converter. It's also powered with 3.3 volts and uses I2C to communicate with the ESP. I know the ESP itself has many analog to digital converters, but they are heavily dependent on the input voltage as their reference voltage is directly tied to the input voltage. The ADS module, on the other hand, has its own internal reference voltage, which provides very high stability, thus very accurate readings. I'm using this component to read the voltage provided by the external pressure sensor, which reads the pressure in the entire system, and for the SCT013, which is a current transformer which is responsible for reading the AC current the VFD uses. Now let's jump to output modules. One of two is the solid-state relay board. It consists of 4 solid-state relays. They are like normal relays, but only for AC current. With normal relays, you can switch DC voltages, but not with this one. It will simply not work. I've used this because I'm not planning on switching this DC voltage. Solid-state relays are quiet and a little more robust than traditional relays. This one is powered with 5 volts and the inputs are simple high signals from the ESP. The second output module is the 0 to 10 volts converter. As the name suggests, on its output you get the 0 to 10 volts analog signal. On the input it takes the PWM signal from the ESP and converts it to 0 to 10 volts signal. It's used to drive the VFD, as devices like this usually take this kind of signal to set the desired drive speed. This module is powered with 12 volts because any lower voltage than this would not be enough to produce a 0 to 10 volts signal. Last but not least, we have all kinds of screw terminals, GX16 connectors and 3.5mm jack connectors. All of them perform one very important task. They connect everything outside the controller. Jack connector is for SCT013, the current transformer. GX16 connectors are for LCD and UART connections, and screw terminals are for everything else. In conclusion, even such simple looking contraptions can look complicated and overwhelming. But in reality, when you take a closer look at each component separately, it all comes to one logical system. There's no unnecessary components, everything has its own purpose, every component is as important as the others. And the code running on the ESP is a logical network which synchronizes and connects everything together. Sometimes it's easier to look at each component as its own and then connect everything together. This way you can understand even the most complicated systems. That's it for today's video. As always, thank you for watching and I will see you in the next one.